Okay, great. So we should be recording now. All right. So yeah, welcome to week 4. Let's quiet down in the peanut gallery. Thank you. Okay. So, all right. So this week we are going to be diving into the exciting world of inheritance. Taking a step back and thinking about how we can use object-oriented programming to write software that is easy to maintain, easy to extend to new use cases, robust to different inputs, and generally useful in the real world. So today, let's see, we will start learning about inheritance. After today, you should be able to get started on Lab 3 if you would like to, although we will get more practice on Wednesday, and so you can also just start after Wednesday, and that will be totally fine. But I wanted to start off by opening up the floor to any questions on Project 1. If anybody's stuck on anything, go ahead and raise your hand right now, and we can try to address that. Or if there are any things unclear. I'm not seeing any hands, so great. Another thing that came out of the lab last week, I had one of the course assistants ask me to remind you all that, or maybe tell you, because maybe I haven't even said it explicitly, that a really important convention in Java is that our variable names start with a lowercase letter. So Java will enforce that your class names have to start with an uppercase letter. Actually, I'm not positive about that, but certainly we've been doing that in class, and I haven't heard of any problems with that. But I know that it won't force you to have your variable names, like for example your fields. Oh, that's not the right one. This one. Maybe if we're going to take a look again at our credit card class, but, you know, our fields here, these are variables. They all are starting with a lowercase letter. And generally in Java we use camel case. If we had a constant, and usually we would actually put those first. So if for some reason our credit card had a constant field, then we would also make that, the convention would be to make that all uppercase. So something like in your project you have pi, and that's all uppercase, so that's a convention there. That your constant, so things that are final, are all uppercase. Variables in general, whether they're fields, whether they are parameters, or whether they're just something that you make inside your methods, those should all be lowercase. Your class names, of course, start with an uppercase letter. Does that make sense? Any other style questions? I know a lot of the Project 1 is actually style. You get 20 points out of 100 for having good style in your code. So if there are any questions right now, yeah, I see a hand.
So with Project 1 of the constant fields is the usage instructions, but that isn't uppercase. Do you want us to make that?
No, that's a really good question. And I think because that is a static variable, and let me in Discord or maybe at next class give a better explanation for that difference, but that is a good point, and so that is one difference, that's final, that's something, those instructions aren't something that we should change, but it's not a constant value that you're going to be using throughout the program, so the convention doesn't hold there. But I can try to look up what the specific convention is, because that's, to me, it's kind of just like oh, I have practice with this, and so I do what I do, and I don't actually have a rule for it. So I will get back to you on that one. Yeah, thanks for that question. Any other style-related questions as you're working on Project 1 or just in general? Yeah.
I'm having a hard time, getting the right justification, or
yeah, the right justification on the
when I print the answer.
Yeah, the print answer. Did you follow that link in the method?
Yeah, I looked at the link, and when I printed it out, it just printed the straight up %15s.
Do you have a couple minutes after class? Yeah, let's look at that after class. But yeah, definitely make sure that you follow that link if anyone's having trouble with that. Yeah.
Kind of just like in general, when we're given like the kind of like base code to build off of, do we always have to like use all the parts of it, or like what's kind of the goal there? Are we trying to like simulate working with other people's work, or?
I would say both. Simulating working with others. So if you are a software developer, or even like as a researcher, I often am building off of other people's code. And so, nobody's grading you when you're a software developer. Nobody's grading you when you're a researcher, but you want to be able to read the code and figure out what you can use. I will try to provide you with something to start with that is useful, but unless it says in the grading that you're required to use something, you shouldn't be required to use it. Although, please ask me questions, because, I can make mistakes, or maybe I can just make something generally more clear. So unless it's in the grading, you shouldn't lose points for it, but also please ask me if you have a question. So, and then also, so it does simulate being in a real working environment to have code that you start with. Also, it lets us practice these concepts that if you had to write these, if I gave you this assignment without starter code, I think it would be a lot harder, and a lot of you would make design choices that would make it very hard for you to write the calculator. So this, for this first assignment, all of the actual engineering of how should we solve this problem is done, and then you're working on the implementation details. This week we start on our object-oriented design, where you're going to be start making those choices, like what gets to be a superclass, what's a subclass, etc. So we'll talk more about that. All right, cool. So thanks for those questions. I wanted to show, okay, this was Project 1. I wanted to show that from last Friday, we started looking at the credit card class. And we're going to come back to this today, but I just wanted to show, in case you didn't look at it, we didn't get very far on our credit card, but on our credit card class and our credit card demo, but the full code for those is here. And so you have that as a resource as you are writing your own programs. Like if you forget, how do I make an array of an object that I defined? There's an example here of, we make a length 3 array of credit card items, or credit card objects. And so here you have an example of that syntax. Or if you're like, what is the syntax for a for each loop? We have an example of that here. So even though we didn't write the whole program in class, you do have those. I also put the UML diagrams that I wrote up, and then the one that we implemented down here. So you have all that. You don't have to look at the video or anything to get there. All right, so on to today. Let's get back to that. So, all right, so 3 big ideas in object-oriented design that we will continue to come back to are abstraction, encapsulation, and modularity. These are kind of like long words, but for, I think, really powerful concepts. So what abstraction means is that rather than necessarily focusing on the implementation details, we can simply, when we're writing software, be given an interface. So what is that? A description of the methods of an object. And from there, we can interact with that interface. And a class, what we've been implementing, is what actually implements that interface. So the idea here is that we have abstracted away from the implementation details to just the part that faces the user. So like, for example, with my laptop, like the interface of my laptop is the keyboard and the mouse and the screen. I don't really know how my laptop works inside, and that's fine. Like that's how we interact with the world all the time, is through abstraction. We don't know what's going on inside the laptop, but we use it, and that helps us organize like our actions in the world. Similarly, or sort of building on that idea, another principle in object-oriented design is encapsulation, which says that we do not need to reveal those implementation details. We just need to maintain the interface and make sure that that's correct. And finally, as we're designing our systems, we want them to be modular. We want different components of the system to be logically based in their functions. So to make this a little more concrete, even though we will then make it even more concrete in terms of our Java code, a really important concept that we'll learn about today is inheritance. And so inheritance is based on these hierarchical ISA relationships. So for example, how is this looking on size? Let's go there. So for example, this is from your book. An ISA relationship regarding architectural buildings. At the top of our hierarchy, everything below the building is also a building, right? Like a house is a building, a commercial building is a building, an apartment is a building. And then at a lower level, within apartments, we could have low-rise apartments or high-rise apartments, etc. And here's one question. In terms of buildings, like, is this the only way, is this the only way that I could have made an ISA relationship between buildings? Like, is this fixed, like, there's only one way to do this? Yeah, no. I mean, depending on my purpose of my system, I might not have divided buildings into apartments, houses, and commercial buildings. Like, maybe it would have made more sense, depending on my application, it would have made more sense to just say, well, buildings are either residences or non-residences. And then apartment and house would be below residences. In this specific hierarchy, we happen to have defined apartment and house on the same level, below building, and hopefully there would be a design reason to do that, but there's not only one way to do this. And this is kind of what I'm talking about when, even with our calculator, there could have been a lot of ways that we designed that system, and probably a lot of good ways, but also there can be some not so good ways. So, any questions or comments on this is a relationship idea? Or any anticipation of how we're going to use this relating to classes in Java, or questions about that? Yeah.
You have multiple, I guess this might be skipping ahead, but you have multiple types, like multiple, you have it, kind of flowing upwards one way.
Yeah.
But I've read before, just briefly about inheritance, that there's only a limited number of types of inheritance in Java. So I guess what's allowed and what's not allowed for inheriting. And this is just too ahead of time. Then let's wait.
No. So one thing that I'll note is, if we had not only, it's not like everything in our program is going to need to be part of the same hierarchy. So maybe we have our buildings, and it's useful to have this hierarchy regarding our buildings, but maybe there are also like residents, and that is or like people. Maybe our system also has people in it, and people are not is a relationship with buildings, but they do interact with buildings. And so either maybe a person could be maybe a person could have a field that holds, their residence and their workplace, and those are buildings. Or maybe it's the opposite. Maybe a building holds a person as its user in some way. But we definitely don't need everything to be part of the same hierarchy. We will learn about specific rules in terms of inheritance. Otherwise, yeah.
I'm a little curious. Do you run into inheritance a lot? Because I've heard that in professional work it's a little bit limited.
That's a good question. For me, I am usually writing software in a research setting, and it's a lot more one-off or only a small group of people is using it. In terms of if you're a software developer at a company that has hundreds of software developers, my guess is that it would be a lot more useful. But yeah, I would like to have, I guess I don't have a really good answer to that. I would be happy to ask people that I know that work in industry and get back to you, because I also have that question. So let me write down that one as well. I can say that as reading other researchers' code, I do wish that their software was developed in it would be a lot more reusable if researchers used object-oriented principles. Because when you want to make a small change, it's really nice when you're dealing with things that are abstracted, rather than just lines of code that just do this thing, do this thing, do this thing, do this thing. And if you want to make a small change, just how something works, and it now goes and touches one single line in a bunch of places, rather than just, oh, the apartment needs to have this method now. That's a lot easier to make that change. So I can say that. Okay. Great. So what does this look like in actual Java code? So we'll start with our UML diagram that we saw last time. So we have our credit card class. I guess I'll open this up. Oh yeah, well, I already have it open. This is the credit card class. This is not part of it. From the book. And so we can see that there's a constructor that we didn't implement in here. There are a lot more methods in here that we didn't implement on Friday, but they're pretty straightforward. Get the customer, get the bank number, etc. The only difference between the charge method that we implemented on Friday and the book's charge method is that, well, actually, can anybody spot it? Or did anybody take a look at it over the weekend or anything? Anybody remember ours? Or remember implementing it on Friday? Someone remembers it. I saw a nod. Anybody remember what type our charge method returned? At least the one that we wrote, the one that I wrote. I'll pull it up. On Friday was right here. This is what we wrote. We wrote a charge method. It also took in a double, and it used an if statement to check that the charge wouldn't bring us over the credit limit. But can anyone tell me the return type of this method? Yeah, it doesn't return anything, which is a totally reasonable thing to do. However, the book's credit card class, anticipating that they want to use this to demonstrate inheritance and have some more functionality, theirs returns a Boolean, so a true or false. And can anyone tell me, just looking at this code, when would it return true and when would it return false? Like, in what conditions? Anyone that, yeah.
If the not to be added plus the balance, it's going to put it over the limit, it returns false when it's not going to return true.
Yeah, exactly. So that's how this charge works. We also have make payment. So the balance is what's keeping track of the credit card balance. Make a payment deducts from that. And then there's this utility method that can print out information about the card. So coming back to this UML diagram for the class, we can see we've got our fields. We can remember our class name goes at the top. We've got our fields. Does anybody see anything on here that we didn't cover on, like something weird in the fields? Yeah. Yeah, exactly. So here we have this pound symbol, and we only learned about the minuses, which meant that it was a private field or private method, and the plus, which meant that it's a public field or public method. The pound sign is for protected, which I didn't talk about before because we didn't know about inheritance. Protected is, I kind of think of it in between private and public. So protected means that it can be accessed by the class itself and also its subclasses. So in the thinking about these, if I have a class representing my high-rise apartment, then that's a subclass of apartment, and it's also a subclass of building. And so then that means that the protected fields and methods can be accessed by the subclasses, as well as the class itself. Yeah, otherwise I think this should make sense. We can see that charge, like I mentioned, the charge method, they called it price, what it takes in, but it's a double, and it returns a Boolean, We can see that again in the actual Java code. Charge takes in a double price, and it returns a Boolean. Okay, so now let's say we have our class credit card, and we want to represent one of these is-our relationships between our credit card and what we're going to call a predatory credit card. So a predatory credit card is a credit card, but it has some extra fields. It has, well, actually just one extra field, and it has some extra methods as well. So we say that the predatory credit card extends the credit card class. We also say it's a child class of the credit card class, or a subclass. Let's look at the notes up here. Yep, so a subclass or a child class, these are synonyms. You can use them interchangeably. I will use them interchangeably. Extends a base class, parent class, or superclass. Again, all synonyms. You will see them all. You can use them all. And another thing is that the child class, it can, here we're just seeing that the, okay, I guess the child class, we can say it augments the superclass or the parent class by adding new fields and methods. So for example, my predatory credit card is adding the field APR. I forget what that stands for. Something, what was that?
Annual percentage rate.
Yes, annual percentage rate. So that's like the interest rate that the credit card is charging. That's the only, I only know of credit cards that do charge interest rates, but apparently in the world of our book, there are credit cards that don't charge interest, so good for them. But the predatory credit card adds the APR field, and it adds the process month method. So what that just actually charges the interest. But also, so that's augmenting our parent class. It can also override an existing method, and we will possibly see that at the end of class if we have time. Maybe we'll see it in the next class, but we can see on this diagram they both have, like, credit card has the method charge, and so does predatory credit card, and that's because predatory credit card actually writes its own new charge version that overrides the parent class charge. Just in case this isn't clear yet, so let's say I make a predatory credit card object. Does it have a get account method? Yeah, I'm hearing yes, I'm seeing some nods. Exactly. The idea behind inheritance is that instances of the subclass inherit everything from the classes above them. How about if I make a instance of a credit card, does it have a process month method?
No.
Yeah, it doesn't have a process month method, as written here. Okay, great. Well, let's try to, let's just make sure that I didn't skip anything that I really wanted to say. Yeah, let's take a look at our credit card class one more time, and try to start implementing this predatory credit card class. So I'm also going to open the credit card demo. If you don't have this, this is both on the lecture 8 page and the lecture 7 page. And yeah, we didn't go over this, but in class, but what's happening in this demo is we're making an array of credit card objects. We're creating credit cards to put in each slot of that array, we are calling the charge method on each of those credit card objects, accessing them through the array, and then, so we charge the credit card, and then we are actually calling make payment as well. So we have our credit card demo, it runs, and now I guess I actually have one in here, but I'm going to delete it. So in my same package, I'm in my day 8 package. I'm going to make a new class, which is going to be my predatory credit card. And okay, so the first important thing here is that if I want predatory credit card to inherit from credit card, it's not enough that I just called it, predatory credit card. The computer, Java doesn't know what I mean. I need to use extends. And that is my keyword that is going to say that this should inherit from credit card. Okay, here we go, credit card. Let's see. I guess it wants me to have a constructor, that's fine. So just like any other class, I might have my fields, my constructors, and my methods, but since this is inheriting from credit card, I know that I actually have all those fields from the superclass, from the parent class, but I'm going to define an additional field or an additional instance variable. And okay, let's actually follow my UML diagram here. So taking a look at this, can anyone tell me what I should write to define that field? Any other hands? Yeah. Yeah, exactly. So I need to define this field, APR, because it's in my diagram. And that is that. So now let's see. I'm going to make a specific constructor for this class. I'm going to make this public, and as always, my constructor has to have the same name as my class. And I'm going to have this taken all of those, I'm going to have this taken all of those same inputs from my regular credit card, so I'm just copying them over to save myself some typing. But I am missing one thing, which is I need to also initialize the APR, so I'm going to call this the rate. That's what the book calls it, at least. Seems like a good enough name to me. So one way that I could do this, so hopefully we can all guess this, but one thing I could do here is just say, actually thinking about, so one way I could do this is I want to do something like customer is what I passed in for my customer. I want to do something like my bank is what I passed in for bank, etc. All these things, I could list this out. But in this case, a nicer way to do this is going to be to use the constructor for my credit card. And so if you remember, we had this, which called the constructor for a class itself. So similarly, we can use super to call the superclasses constructor. So if I use super, I can just pass in, like let's remember what the credit card constructor does. It takes in all 5 of those fields, right? It takes in the customer, takes in a bank, takes in an account, a credit limit, and initial balance. So I can do that as well. And I want to pass in the ones that I am getting from this constructor, right? Count, limit. Did I miss one? Yes. I missed the balance, right? Initial val. And so by using super, I'm going to call the superclasses constructor. And so all of those fields get set. So that is nice. This is a nice, did you have a question? Yeah, here, go for it.
Okay. When we're doing these extensions classes, do they go within the other classes?
Yeah, that's a good question. I think the answer is no, but it's always worth checking because I think that in Java we have to put every class in a separate file. I don't know if there's an exception for subclasses. So how do I test that? Well, I just try it out. At least that's my way that I answer questions about Java and about all programming languages is first I try it out, or I do some combination of trying it out and Googling it. And yeah, and I guess one reason like that starts to make sense to me at least is that so I'm getting an error. My guess is if I were to like try to run this, oh, maybe it does let me do it. Oh, what happened? I'm gonna delete this so that it's not there. So I just pasted my whole predatory credit card, all my code that I'd written in its own file into the bottom of my credit card.java file. And now I'm gonna try to run credit card demo. And I guess it's running. Oh, but I haven't tried to let's make a predatory credit card at the end of this here. So, anyone want to tell me how I make a predatory credit card? Yeah.
So you take predatory credit card, and then in parentheses, put all of the same.
Yeah, I need all that, but yeah, exactly. So that's how I call the constructor. I want to actually save this as a variable so I can like call something on it. I'm going to call it card, but then exactly like you said for how I call the constructor. And I'm just going to steal the input from one of these previous ones. So I have in this case, this is the limit. I'm going to start with a balance of 0, and I need to put in a rate. So I'm going to do like 10.5. I hope that makes sense as a rate. Okay, so,
Semicolon at the end there.
Yes. At least that's going. Okay, so I finally was able to get Java to tell me the answer to my question which was, can I put both of these classes in the same file? The answer is no. predatory credit card must be defined in its own file. So, and yeah, the one way that I would remember this is that, personally, is that I always have to name my file the same as the class name. And so if I have two classes, what's the file name? Is it, which one is it? So now I'm going to save this, and telling me you have an error. Who knows? Maybe it's because I haven't set APR, but let's try running this now. And oh, I need my package name, what is this? Yeah, package day 8. And now it's looking like, even though I have the exact same code, I just have correctly put it in the right files. And so, great. So, okay, well, I haven't set my APR yet. So, since that has nothing to do with the superclass, I'm just going to set it how we normally would. So, APR equals this rate that I've passed in. Okay, great. And so now I'm going to go back over to my demo, and I've made this predatory credit card. And just to check that it's working, I'm going to call card.getBalance and print out that result. I initialized it with a balance of 0, so I'm expecting it to be 0. Maybe I'll comment all of this stuff out here just to make this really easy. And indeed, I have a balance of 0. So that's good. All right. Now, okay, we have our credit card has a charge method, right? So what happens if I do card.charge, and let's say I charge it $500, and then I call getBalance again? Well, even though we didn't implement, so card is a predatory credit card, we didn't have to implement charge. It's inherited from the superclass. So when I run this, it still works. All right, let's put in a new method. So new method for this class. So we've already inherited all the methods from the superclass, but let's get that process month method. So that should be public. It doesn't take in any parameters, and it doesn't return anything. So public void process month. And what should this do? Charge monthly interest. Monthly interest if there is a balance. So first, let's check that there's a balance. So if and our balance variable is just called balance. If that is greater than 0, we should do something. So you'll notice, again, that balance field is just being inherited from the superclass. So what should we do? Well, we want to charge a, let's see. First, let's compute the monthly rate. And then let's make the update. I would have definitely had to look this up myself, but luckily your book already had it. The way to compute the factor by which we want to multiply our balance, if we have the APR, we can compute that as, and here we can see that we're using the math package, the built-in math package from Java. We can compute this as, let's add 1 to our APR. Oh, I wonder if I did the wrong, I wonder if I should have done APR as like 0.1. Possible. Because here they're just like adding 1 to 10 doesn't really make sense, but adding 1 to like 0.1 would have made sense. And then if we want to charge this interest, you know, we're going to charge something. We want to multiply our current balance by that monthly factor. We can use the times gets operator. And I really want to spell monthly without an H, but it does have an H. So this is how we can implement this process month method. And now our credit card, our predatory credit card, should have this method. Card.processMonth. Doesn't take in anything. And so we should, after we process this, at least we should know that like we should increase our balance, right? Like I don't know how much it, off the top of my head, I have no idea by how much it should increase, but certainly it should increase. And it did increase, so that seems like a good sign. So we've now added a field and a method to our child class. I meant to go over Lab 3 a little bit today. I will do that at the start of Wednesday instead, but you can start on that. One thing I'll note before you pack up, I guess, just to let you, I'll go into more detail on Wednesday, but actually, if you download the sample code, one thing that at this point we still haven't talked about, so I'm going to open Lab 3 Starter. I'm going to open petdemo.java. Lab 3 Starter. Oh no, I'm going to open pet.java. So one thing we haven't covered yet is that this is called an abstract class. We'll talk about it on Wednesday, but you actually can start implementing this. The only thing about an abstract class is that in the parent class, it can have these abstract methods where the parent doesn't have an implementation, but all the children are required to have an implementation. So you're going to make 2 child classes of pet. You're going to make a cat and a dog. And what it means when we say that pet is has an abstract method, it means both cat and dog are going to have to implement this method, even though there's no superclass implementation. So you should be able to get started on this. All right, thanks everyone, and I will see you on Wednesday.
For some reason, that predatory course that saying is not usable. I don't know if this is because that's private here, but
Yes, I forgot to say that you should change that to protected.
That all makes sense.
Yeah.
okay. So I just have to show that if I wanted to, in order to have one of these classes.
Yeah.
These all have to
Tyler,
be
did you
public then.
finish up Lab,
No.
whatever, Lab 3?
Because otherwise, like, none of this works.
Yeah, no. But
It's all kind
I
of fine.
tried to talk to her about the question 3 of the
I just
first lab.
changed the one variable to protect.
Yeah, didn't go well.
So I think because
It's like,
because we're calling the
you
superclass,
have tension on the thing.
So if that is
was your value
protected-
too high or too low?
or it could be
I
both.
said
Like
too
public
low,
or
yeah.
but
Okay.
protected
Is
would be
the-
the kind of like nicer way to do it because you're not
Are you saying
opening
the
it up
value
to
of the
everyone.
friction
You're
is too
opening
low
it
or
up.
the value of the tension is too
The
high?
friction's
And as long as
if
you-
you
But yeah,
force gravity,
I forgot
force
about that.
friction, and then you add tension to that. But it's
Yeah,
same
then
force
the
gravity.
measured force of
Yeah.
friction is
You know
too
what? This
low.
would be
Yeah, and that's in your work
equation.
equation.
I'm trying to
Yeah,
make
which is
this
on top.
Okay, so let's talk